Okay, we're going to find the first four non-zero terms in the expansion of square root of 1 minus 2x. So, formula for 1 plus x to the power n. This now does not have a restriction on n. So the binomial expansions you did before, n had to be a positive integer. Now n can be any real number. The difference is there's now a restriction on x, which is what you're putting into the expansion. X has to be between -1 and 1. If x was 1 or bigger, when you put x into a bigger and bigger power, the terms in the series will just get bigger and bigger and bigger and bigger and bigger, and it will become completely meaningless because it will diverge. Whereas if x is between -1 and 1, when you raise x to a bigger and bigger power, each term in the series approaches 0, and so the series will converge because you'll be adding on a smaller and smaller amount each time as you move through the series. So just to make this clear, this modulus of x means the positive value of x is less than 1, and that's the same thing as saying that -1 less than x is less than 1. So x is sandwiched between -1 and 1. This pattern just continues. There is a general form for it in the formula book, but as long as you understand the pattern, you'll find. So n minus 1 over 2 factorial. The next term along is n minus 1, n minus 2 over 3 factorial x cubed, and then the next term would be n minus 1, n minus 2, n minus 3 over 4 factorial x to the power 4, and so on. Right, we've got square root of, wrong colour, 1 minus 2x. First thing to do is to write that in the form 1 plus x to the power n. So if I stick a bracket around it, and square root is power 1/2. So in the expansion, the sign needs to stay with the 2x. So if it's a plus, it's a plus. If it's a minus, it's a minus. So you replace x with minus 2x, and you replace n with 1/2, and then it's just a case of plugging in. So I get 1 plus n is 1/2, x is minus 2x. I would use quite a few brackets. Remember to bracket your negatives. I tend to bracket the tops of these as well. So n is 1/2. 1/2 minus 1 is minus 1/2. 2 factorial is 2. And then x is minus 2x. It's just remembering to put that minus 2x in as well. And then we've got n minus 1 is minus 1/2. n minus 2 minus 3 over 2 over 3 factorial, which is 6. So careful of that, 3 times 2 times 1, and x is minus 2x cubed. And then it's just a question of sorting out what you've got. So 1/2 times 2 is minus 1. 1 is the first term. Second term will be minus x. So if you're asked to find the first 3 terms, you can stop after the next term. 1/2 times minus 1/2 is minus 1/4 over 2 is minus 1/8. Minus 2x squared is 4x squared. And then again, at this point, you might just think, oh, I'll put it into a calculator. So you've got that lot there comes to a 16th. And minus 2x cubed is minus 8x cubed. And so first 4 terms, 1 minus x minus 1/2 x squared minus 1/2 x cubed. So it's just an algebraic exercise really. And then you need to sort out your validity on x. So which values of x are valid for this expansion? And whatever you put into it needs to be between -1 and 1. Because we're putting -2x in, I'll just show you this. If I times that through by -1, then you change the sign, and that's exactly the same as having -1 less than 2x less than 1. So you don't have to worry about the fact that you're putting a negative in. So -1 less than 2x less than 1. So what you're putting in needs to be between -1 and 1. Then I've got an inequality which I can divide through by 2. You could leave your answer like that, or you could write it as a modulus, so modulus of x less than a half, but you have to have, you can't leave it like that, and you can't leave it as modulus 2x less than a half. You have to have x on its own in the expansion. Sorry, think about something else. X on its own in the validity for x. And then when you times x by 2, whatever you've got is between -1 and 1, and so the expansion is valid. Hopefully that's all right. Just to show you really quickly, if you've got fractions, so say you've got 1 over 1 plus 3x, I can write that as 1 plus 3x to the power -1, and then you can plug into your expansion with n equals -1, and you this time would be replacing x with 3x. So you can turn your fractions into negative powers as well. So we have a go at a few of those, and then we'll put a couple more layers onto that.